a little weird and takes some getting used to. By default, most instance variables are protected. Okay, they're essentially private. Whoever's using your class, they can call your public methods, but they can't access your instance variables. So our calculator brain only has one instance variable, which is its operand, its internal operand, or at least it's going to start out that way with only this one instance variable. Notice it's a double, okay, double precision calculator. And then our method declarations for our class go here in this space after the instance variables and before the @ end. And we're going to have two methods for our model. One is to set the operand, and then the second one is to perform an operation on the operand. And it's actually going to return the updated operand just as a convenience to have fewer methods and to make it kind of simpler. Notice that the set operand method, its return type, the kind of thing it returns, is void. Okay, that means it returns nothing. This is different than just not putting that parentheses there at all. That means something different. That actually means it returns an object. So if you have a method that returns nothing, you need to say parentheses void as the return type. Notice the other one is parentheses double. It returns a double. Okay? This is the name of this method. Set operand colon is what we would say. Some people might say it's called set operand, but usually if it takes an argument, we say the word colon when we're saying the name of it. And I'll show you in a second what happens if it has multiple arguments, because it's kind of funky. Definitely not what you're used to. This is the only argument to this method. It's a double. Okay, it's called an operand. That's just going to be the name of the local variable inside our implementation. Since this is the header file, you could really call that anything you wanted. Again, only one argument in this method. Don't forget to put a semicolon at the end of this. Just like in any other C-based language, semicolon is the end of this line. White space generally doesn't matter in here, although there's some places where it matters, and we'll talk about that later on in the quarter. So this method returns a double. It takes an argument this ns string star, so it actually takes a pointer to an object as its argument. That's what ns string star means, a pointer to an ns string, an object of class ns string. And we'll talk a lot more about how we pass objects around. All objects in Objective-C are allocated on the heap, so you always have pointers to them. There's no way to allocate them on the stack as a local variable or any of that business. They're all allocated out of the heap. This argument called operation, again, doesn't really matter in our header file. So here I've thrown in a wacky method. This is not part of our calculator brain, but I just wanted to show you what it looks like if you have two arguments. So this method has two arguments, and it would be called foo colon bar colon. That's what people would call this method, foo colon bar colon. Not foo bar, foo colon bar colon. Okay? And, the first argument, notice that the arguments like zap and pow are interspersed between the names. It's not like Java or C++ where you have the long name of the method and then open parentheses and then all the arguments separated by commas. Okay? The name of the method and the arguments are kind of interspersed. The reason Objective-C does that is because the goal when we write good Objective-C code is we want it to read as close to English as we can. Okay? So we want those argument names, the name of the argument like foo colon, to match up with the thing we're passing in a readability way as we read left to right. And you'll see a lot more of this as we write more and more code, why this makes sense. It's actually kind of nice. This one returns a pointer to an object, an NS array I've just made up here. Okay, so that's a pointer to an NS array. It is possible for these pointers to be nil. Basically, there's a keyword in the language, nil, which means there's no pointer, basically a nil pointer. Dereferencing a nil pointer by sending a message to it does not crash your program. So that takes some getting used to. Okay, so it's not like a void pointer. It's a little different than that. Notice this second argument. Its type, ID. See that type? That's a new type. That's Objective-C only. That means pointer to any object. So you can pass a pointer to any object. You could pass a string in here, an array, etc. And you might say, whoa, wait a second, that's pretty dangerous, because what if this method thinks that this object is a string and I passed in an array and it's going to crash? And yeah, that's true. Luckily, there are ways in Objective-C to ask an object, what is your class? Or do you respond to this method? So that you can prevent yourself from crashing by asking that question first. And then you're going to see how we can take an ID and put a little bit of extra syntax in there to turn into a protocol, where it's any object that responds to a certain protocol. Okay? So I'm going to take off the foods app. So this is basically the starting public API of our model. I'm going to be adding a couple of instance variables I'll need in my implementation, but that'll be a little later. So now let's look at Calculator Brain's implementation. Yeah, question?
What is the negative sign at the start of the
Oh, yeah. So he was asking, each of the methods had this dash at the beginning. That's either a dash or a plus, and I'm going to talk about what that means next week. But basically, a dash means it's a message you send to an instance. A plus means it's a message you can send to that class. And that probably doesn't mean a lot to you right now, but next week it'll mean a lot. So for now, it's always a dash. We'll talk about plus next week. So this is calculatorbrain.m. It's the implementation of Calculator Brain. So it's going to have implementations of all those public methods, the two that we declared, and also it's going to have implementation of private methods that are only for us to use. Okay? We obviously have to import our own header file. I forgot to say, you see the @sign implementation, @sign end. That's similar to @sign interface, @sign end, except for this is our implementation. Also, notice we didn't put the colon NS object. We don't put our superclass here in the implementation. But we do have to include or import our own header file. And that's so that our implementation knows what our instance variables are and things like that. So this is what it looks like to put method implementation in. Almost exactly the same as the header file, but no semicolon and curly braces instead. Question? Yeah, the question is, do we ever need to use include versus this thing import? If you look at import, it kind of does all that magic includes for you, so that if you include something else, and you get these roundabout things, it manages most of that, not all of it, for you. So # import is the way we include header files in Objective-C. We never use include. You would never use it in your code. But it is a strict superset of C, so # include is there, it's just we don't use it. Okay, so back to this. Set operand, no semicolon there, but curly braces instead, and the code goes here. So set operand, for example, its implementation, no semicolon there. Its implementation, very simple, operand equals n operand. Okay, that's going to be the entire implementation of that method, super simple. We have another method. I'm not going to show you the implementation of that method in the slides. I'll show you when we do the demo. But I wanted to show you what it looks like to send a message. So we talked about declaring methods and objects, but what about sending them? And this is what it looks like. There's this kind of funky square bracket notation. Okay? You basically put square brackets at the beginning and at the end of your message send. All right? And the first thing after the square bracket is the object you're going to send the message to. Here I'm sending this message called send message : to the operation, which is this NS string star. Okay, so it's a string message. So this send message that I'm sending better work on strings, because that's what I'm sending, right? Send message to it. And then this is the argument that I'm passing along with send message : Okay, so I just wanted to show you that syntax. Obviously, our implementation of perform operation is going to have a lot of different stuff in there. Okay, so that's the model's header file, its interface, and now its implementation. The last thing I'm going to show you is the controller, its header file. We're not going to do its implementation, but we'll show its header file. So a couple things to note here. One is our controller inherits from a class in the iOS SDK called UIViewController. See it there? And that's why I'm importing uikit.h, which is the UIKit's master header file. The UIKit is a thing that has buttons and sliders and view controllers and views and things like that in it. So I have to import that because it's my superclass. Okay, so note that. UIViewController is how the UIKit plugs into your MVC structure. Right? So MVC is part of how the UIKit expects you to do your work. It's not just a nice idea to make it work. It's actually part of how the UIKit expects you to behave. So this first instance variable, right? This is an instance variable and public header file here. Instance variable is our brain. This is, if you remember our MVC model, this is the pointer over to our model. Okay, and remember that our controller can talk to our model as much as it wants. So that's a green arrow. That's what that pointer is. Then this pointer, the display, as well as these two methods, are the target action thing, the little that we hung up, and also the green arrow that can go from a controller to its view. So the display is that green arrow that goes from the controller's view, and then these